Okay, gang. Let's see. This should be the last video for the week for geometry. I left you a message today about the quiz for next week. The quiz is posted. It's due next Monday, and there's some instructions to make sure you follow on the feed for the class. Okay, so one more of these. I know we did two of them yesterday. We'll do one more. Okay, so let's see. We have a quadrilateral ABCD, and it is inscribed within a circle because all four vertices are on the circle. So if that is the case, both pairs of opposite angles have to be supplementary. Okay, so A and D have to be supplementary, B and C have to be supplementary. Okay, so I'm going to start with angles A and D. Okay, so we know that the measure of angle A plus the measure of angle D have to be 180 degrees. Okay, so the measure of angle A is 12x minus 1. The measure of angle D is 17x minus 22. And when we add those together, we have to get 180 pesos. So we just collect similar terms. So it looks like I'm going to get a 29x minus 23 equals 180. Okay, so if I add 23 to both sides, I get 29x equals 203, and then I have to divide by 29. So just go to your calculator, 203 divided by 29, and I'm getting x equals 7. Okay, so let's see, we have to go back up here. Okay, let's see, I'll evaluate to find angle A and angle D. I'll do angle A first. Okay, so we get 12 times 7 minus 1. So let's see, that would be 70 plus 14, so that's 84 minus 1. So it looks like we're going to get 83 degrees there. Okay, let's see, we come down here, we do 17 times 7 minus 22. So let's see, 17 times 7, that would be 70 plus 49. I'm pretty sure that's 119 minus 22. So it looks like I'm going to get 97 pesos. Pretty sure I'll check that in my calculator just to be sure. 119 minus 22. That makes no sense. 119 minus 22. Yep, 97 pesos. And if we look at angles A and D, notice when you add them, you get 180 degrees. So we should feel pretty good about our answers. Okay, so now we go to B and C. Again, the measure of angle B plus the measure of angle C. Since they're supplementary, they have to add up to 180 degrees. Okay, angle B is 8x plus 28. And angle C is 13x plus 5, and that's 180 pesos. So let's see, we collect similar terms, and I'm going to get 21x plus 33 equals 180. Okay, so subtracting 33 from both sides, I get 21x. I'm pretty sure that's going to give me 147. Okay, let's make sure, but I'm pretty sure that's what it is. Minus 33, good, 147. And when I divide by 21, wait a minute, are these, yeah, okay, x equals 7. Okay. Okay, so we're in good shape. Okay, so we go back and we obviously evaluate here. So I got to do angle B and angle C. Okay, so let's see, we'll do angle C first. So we go 13 times 7 plus 5. So let's see, that'd be 70 plus 21, so that's 91 plus 5. So it looks like I am going to get 96 pesos. And then we come over here and we go, okay, that's 8 times 7 plus 28. So I'm going to get 56 plus 28. And it looks like that will give me 84. Okay, and then if I look, 84 plus 96 is certainly 180 pesos. So we're in good shape there. Okay, let's see, that takes care of those types of problems. Okay, now we're going to start working on a topic that's we're going to spend most of our time on, okay, next week. Okay, but we have what's called an equation formula, okay, for circles. Okay, sometimes they call this standard form of an equation. Of a circle, okay? And even other times, rather than calling it standard form, they'll call it general form. Okay, so whether you call it standard form or general form doesn't make any difference. And we actually have a formula that allows us to come up with the standard forms of an equation, okay, for a circle. Okay, now there are two different ways to derive this sort of equation formula. You're going to be asked to do this on the quiz for this week that's due next Monday. Okay, so one way to do it is to use the Pythagorean theorem. Okay, so we could use the Pythagorean theorem, and then I'm also going to show you how to do it using the distance formula. Okay, so we have this diagram. Okay, we have the center, okay, of the circle. Now usually, in just about any textbook you look at, we usually let this HK represent the center of a circle. So the H is your X coordinate, the K is your Y coordinate. It's not like it's a rule or a law like you have to do that, but it's just generally accepted. I mean, technically, do you have to use HK? You could use A, B, R, S, whatever you want to use, but HK is the most commonly found. So we have the coordinates of the circle, HK, and we take any point anywhere on the circle at all, okay? And we just let that be some arbitrary x, y, okay? So the x coordinate is x, the y coordinate is y, and a lot of times they'll call that point, they'll call it capital P, okay? You can name it anything you want. Okay, so we know that this distance from the center to a point, and that point could be anywhere on the circle, is the radius. And we know no matter where that point is, that radius is always going to be the same in a circle. Okay, so I want to derive this equation formula, or standard form of an equation, using the Pythagorean theorem. So if I'm going to use the Pythagorean theorem, I need a right triangle. Okay, so we always let the radius be the hypotenuse of the right triangle. Okay, so the easiest way to build this right triangle is to draw a vertical line, okay, from this arbitrary point anywhere on the circle, okay, and then draw a horizontal line from the center. Okay, so this guy right here is a vertical line, and this guy right here is a horizontal line. So we know anytime a vertical line and a horizontal line intersect, they intersect to form a right angle. Okay, so we have a right triangle. Okay, now I have the coordinates of one point of the right triangle. I have the coordinates of a second point of the right triangle. Now I need the coordinates of that third point. Okay, so I've got to come up with the coordinates for this third point. Okay, so let's see, this is a horizontal line. And when we did linear algebra earlier in the year, and it came up at least one other time that I can remember later on in the year, we noted that if we're on a horizontal line, all points have the same y coordinate. So the y coordinate of this point is k, so the y coordinate of that point has to be k as well. So the y coordinate is k. Okay, now this is a vertical line, okay, and once again, as we learned earlier in the year in linear algebra, okay, all the points on a vertical line have to have the same x coordinate. So if the x coordinate of this point is x, then the x coordinate of this point has to be x as well. Okay, so I have the coordinates of all three vertices. Okay, now I know the length of the hypotenuse is r. I know that. Okay, I've got to come up with an expression to represent the length of this leg and the length of this leg. Okay, so if we go here, okay, I'll take this vertical leg. Okay, notice that it goes from point P to this point. And notice that the x coordinates are the same. So all I have to do is just subtract the y coordinates, okay, to get the length of that leg. So just go y minus k. Okay. Okay, now I have to come up with an expression to represent the length of this horizontal leg. Okay, so let's see. I've got this point at one end of the leg and this point at the other end of the leg. And notice that the y coordinates are exactly the same, which means that all I have to do is subtract the x coordinates, okay, to get the length. So I just go x minus h. Okay, so I have everything I need in the diagram. Now I want to apply the Pythagorean theorem. Okay, so remember the Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. Okay, so all I have to do is substitute in what represents the length of a leg, what represents the length of the other leg, and what represents the length of the hypotenuse. Okay, so I have this leg, so it'd be x minus h squared plus this leg would be y minus k squared equals the hypotenuse is the radius, r squared. And we have our general form or standard form of the equation of a circle, okay, which is sometimes called an equation formula, okay, where, okay, the center, okay, is hk and, okay, the radius is r. Okay, so you have everything you need, and that's how you derive that general form or standard form or equation formula using the Pythagorean theorem. Now that's one way to do it, and it's relatively easy to do. There's another way to do it as well. Okay, we can also use the distance formula. Okay, now as I taught you very early in the year, hopefully some of you remember it, some of you might not, the distance formula is just another version of the Pythagorean theorem. So if you could derive something using the Pythagorean theorem, it would make sense that you could also derive something, okay, using the distance formula. Okay, so we have our circle with its center right here, and rather than calling it HK, I called it AB. Okay, remember I told you don't have to use HK. That's usually what you see, but you don't have to use it. And then we just take some random point, as long as that point is anywhere on the circle, okay, and I usually call that point P, and we know that the radius, okay, would be the distance from the center to any point on the circle, and that radius is going to stay the same no matter where we're at on the circle. And then we just apply the distance formula, okay, to the radius. Okay, so remember our distance formula. Distance is the square root of delta x squared plus delta y squared. Okay, well the distance is just the radius. Okay, so that's no big deal. So whether we use d or we use r for radius, it's the same thing. And then we take a look at, okay, well how do I find delta x and delta y? Remember, delta x and delta y, delta means subtraction. Okay, so I subtract the x coordinates to get delta x, so I get x minus a. And remember, that's squared in the formula, plus. To find delta y, I just subtract the y coordinates, so I go y minus b. Okay, remember again, delta y is squared. Okay, so we get there. Now, we know from over here that if we look at this final formula, obviously we do not have a square root in it. Okay, so I want to get rid of this square root. So to get rid of the square root, I just square both sides. Okay, so I get r squared equals, and when I square a square root, I just get the radicand. So I have x minus a squared plus y minus b squared. And then usually you switch the two sides. Usually we have the x and y on the left and the radius on the right, although there's nothing wrong with that. Okay, so we would normally write that as x minus a squared plus y minus b squared equals r squared, where, okay, the center, okay, the coordinates of the center are a, b. Notice that's exactly what they are. And the radius is r, okay? And there you go. Okay, so whether we're taking a look at deriving this general form or standard form or equation form, or whatever you want to call it, using the Pythagorean theorem or using the distance formula, notice that they're both pretty easy. Okay, and that will wrap it up for today. Once again, the quiz for the week is posted already. It's due next Monday. There are some instructions on Google Classroom that I left on the feed to help you out with that. And once again, I miss you a whole bunch, and be safe.